All right, let's try to finish up this section, trig ratios. So let's see, what have we learned so far? We've learned 3 basic trig ratios, didn't we? By the way, when we talk about a ratio, what are we talking about? A fraction. A ratio is basically a fraction. It's a comparison between one thing and the other, all right? Like if you had half a pizza, I don't know, how many slices they slice of pizza? I guess that would be 8, right? So it'd be 4 out of what? 8. And that reduces to 1/2. That's a ratio. You're comparing one thing to another. You're comparing how many slices that you had compared to how many slices were available. That's a ratio, right? And these 3 trig ratios is a comparison. It's a comparison between one side of a right triangle to another side of a right triangle. That's the comparison that we're making. All right, and so our first trig function, we'll go sine of theta. You could use any letter that you wanted for that, but a lot of times we use theta. Let's write it up here. What was it? What was our little mnemonic device? SOHCAHTOA. SOHCAHTOA, all right? And the so, that's the sine. S is the sine. What's the O and the H? Equals what? Opposite over hypotenuse. Okay, that's what that means. All right, so the sine is the opposite over hypotenuse. That's your ratio. That's the comparison that you're making. So when I take a certain angle in a right triangle, not the right angle, but either one of the other 2 acute angles, if I take the sine of it, that basically, the word sine is just telling you what ratio you're taking. What comparison are you making? Okay, what side over what side? That's what the word sine means. And the sine specifically means you take that angle, then you find the opposite side, you put it on top, and you find the hypotenuse and you put it on the bottom. All right? And then you had the cosine of the angle. And again, if you remember this little device, it's very helpful. Does anybody use that to remember your sine, cosine, and tangent? Yeah. After a while, you get so used to it, you'll remember. You don't have to go through the SOHCAHTOA, AH, adjacent over hypotenuse. At first, you're going to have to do that because it's all brand new to you. All right, but eventually you're going to get to the point where you're just going to look at cosine and say, oh, I know that that is the adjacent over what? The hypotenuse. And then the tangent of that particular angle is the opposite over the adjacent. And again, use this little device right there. Use that little trick, if you want to call it a trick, to remember these trig ratios. All right, because it's going to be very important. All right, let's jump to example 2. Did example 1 the other day. Guess that would have been what, on Thursday, right? Today's Monday, so it's been a little while. I said example 2 and I wrote down a 1. That wasn't very smart, was it? Example 2. All right, they give you a right triangle. So let's draw a nice little right triangle here. And, oops, there's your right angle. They give you this is 3. They give you this, oh, actually, they don't really give that to you. Here's what they tell you. Let's write ABC. So they don't come out and just tell you 2 of the sides. Yes. Yes. Is that good? All right. So they don't tell you 2 of the sides, but here's what they tell you. It says, given angle A is an acute angle such that the cosine of angle A, so this is kind of different, the cosine of angle A is equal to 3 over 5. And what you have to do is find the other 2 trig ratios. Find the sine of A and find the tangent of A. Now, you don't even have to find what angle A is equal to. Eventually we will, all right? Eventually we will find out what these 2 angles A and B are equal to each other, are equal to, but we're not doing that right now. All I want to do is find the sine of A. I want to find the opposite over the hypotenuse. The problem is I don't know the opposite, I don't know the hypotenuse. But what I'm going to do is take what they gave us and think about what this means. What does this mean? If they tell you the cosine of A is equal to 3 over 5, what does that tell you about the 3? That's the what side? Cosine. This is cosine. It's adjacent, right? I'm going to put just a. I don't want to put A because you could get confused in there. I'll put ADJ. So this is the adjacent over the what? Hypotenuse. So here's angle A. Okay? What side is adjacent to angle A? AC, this one on the bottom. So what number is that? What's the length of that? It's not X. There's no X. It's just a 3. Everybody see that? This is the adjacent. That's your hypotenuse. So what is AB? It's 5. So when they tell you the cosine of the angle is equal to 3 over 5, that's what it means. Here's angle A, means the adjacent is 3, means the hypotenuse is 5. Does that make sense? They could have come out, and they did on the previous example. On example 1, they told you what this side was, and they told you what this side was. But this, they still told you, but in a different way, a little bit of a sneakier way. Would you agree? All right, so they say the cosine of A is 3 over 5. That means that the top is the adjacent, the bottom is the hypotenuse, and we just put them into that right there. Now, what about BC? You should be able to look at that and figure it out without any math at all. It's 3, 4, 5. That's right. So this would be 4. It's not always going to be a 3, 4, 5 triangle, but in this case it is, and it came out real nice. Okay? What if it was not a 3, 4, 5 triangle? What would you have to do to find this length? You have to do Pythagorean theorem, right? Okay? I'm not going to go through that because it's 3, 4, 5, and we can just figure that out. But if this was a weird number, if this was like a 2, then you'd have to do Pythagorean theorem to get this. Everybody understand that? Okay. So now, it's super easy now. Once I know all 3 sides of my right triangle, I should be able to figure out what the sine of that angle is and what the tangent of that angle is. So what's the sine of this angle? It's the what over the what? It's the, well, give me like in general, not just the numbers right now. It's the what over the what? In general. Opposite over hypotenuse. Now you can go ahead and say it. What's the opposite? It's 4, and the hypotenuse is 5. So the sine of the angle is 4 over 5. And you're probably thinking, and you might have thought this when we first did these, like who cares? Who cares what the ratio of the opposite side to the hypotenuse is? What difference does that make? Well, it will make a difference later on, all right? I promise you it will. Because we are going to be able, if I just know 2 sides of this triangle, I will be able to find exactly how many degrees that angle is. And that can be very important to find a missing angle, all right? Everybody understand that? So just finding the sine of the angle in and of itself doesn't really do much for us, okay? But we need to know what the sine's equal to, what the cosine's equal to, what the tangent's equal to in order to find that missing angle. And we're going to be, I don't know if it's the next lesson. It probably is very soon. I would guess the next one. Yeah, it is. I believe it is. Let me just, I'm flipping pages here. And yeah, it is. We're actually going to find what that angle is in the very next lesson. Is that tomorrow or the next day? That's tomorrow. Yes. So we'll be doing that tomorrow. Okay? Bet you can't wait, can you? All right. So now, what's the tangent of this angle? The tangent is the what over the what in general. Opposite over adjacent. So my numbers are what? Opposite is 4, adjacent is 3, and there you go. So this is what they're asking for. Okay? It's pretty easy, isn't it? Yeah. If you know your SOHCAHTOA thing, it shouldn't be that hard. What if they don't ask you this? I'll do this in a different color just to make it different. What if they asked for the, since I went cosine, I'll put cosine first, then the sine, and then the tangent. Okay? Look what I did. What did I do different? B. So that this time, let's use B. What's the cosine of angle B going to be? It's the adjacent over the hypotenuse, which one's the adjacent to angle B? The 4 is adjacent to it. It's next to it. Some of you might look at it and say, well, yeah, but the 5 is next to it also. Why isn't the 5 adjacent? Because it's the hypotenuse. And the hypotenuse outweighs everything else, okay? It's always the hypotenuse. So what's the cosine of B? It's 4 over 5. What's the sine of B? It's the opposite over the hypotenuse. So it's 3 over 5. And what's the tangent of B? It's opposite over adjacent, which is what? No. 3 over 4. The opposite is 3. The adjacent is 4. Look, do you see any similarities between the cosine of A and the cosine of B? Actually, not really there, but do you see any, I should say this, do you see any similarities between the cosine of A and the sine of B? We talked about this towards the end last time we talked about this. Look, they're the same exact thing, aren't they? So if I take the cosine of A, that's going to be the same thing as if I take the sine of the other angle. You follow me? All right, so that's kind of interesting. All right, that can help you out a little bit. What about this? The sine of A is 4 over 5. What's the cosine of B? It's the same thing, 4 over 5. Do you see that? And what do we do to the tangent? There is a relationship between the tangent. Tangent of A is 4 over 3. The tangent of B is just, you flipped it, reciprocal. Good. 3 over 4. All right, that's good to know because at some point we'll talk about that. All right, there's a little, it's not really a theorem or anything. It's, I don't know, it's in a box somewhere. I taught that in my Algebra 2 class, and we talked about that a little bit. So maybe they'll talk about that. All right, that was example 2. Let's go to something else. This stuff is really what I wanted to get to today. So what we did right there was kind of like what we did Thursday. What we're doing now, it's the same lesson, okay, but what we're going to do now, I can't tell you how important it is for stuff that we're going to do later on. We haven't done the trig yet in Algebra 2. Hopefully, we're going to finish this chapter, then get to the trig, I hope. I don't know. Anyway, my pre-calc class, what I'm showing you right now, I just showed them probably 2 weeks ago. And that's pre-calc, okay? So that's 2 years ahead of you guys. All right, so that's how important it is. Doesn't mean that what we're going to do is super hard, but and it should have been review for them. I don't think it was, but it should have been. So let's do this. Let's have a right triangle. And what I'm going to do is I'm going to draw a 45, 45. Remember we did that? 45, 45, and then a 30, 60. We're going to do both of those, and we're going to learn a couple things that's really going to be helpful to us a little bit later on. I don't know. I'd have to flip through the pages of this chapter to see if we're going to do this, but there's a thing called a unit circle. All right, and when we get to the unit circle, this is going to be very, very helpful. So here's what I'm going to do. I'm going to call this hypotenuse right here, I'm going to call it 1. All right, it's just 1 whatever. 1 centimeter, 1 inch, 1 yard, 1 mile. It doesn't matter. That's just a 1. What I want to do is figure out what this is going to be. Now, if this is, I alluded to it, but this is a 45, 45, 90 triangle, okay? So if this is x, what's this thing down at the bottom going to be? It's going to be x as well, isn't it? So what I want us to do, I want us to solve for x. So do you remember the formula? It's been a little while since we've done this, okay? I'm just teaching this. Well, last week I taught it to my CP class for the first time. So it's been a little while since you guys have done this. But do you remember what the little formula is for 45, 45, 90 triangle? I'll give you a hint. Hypotenuse is equal to, what is it? It's not 2. Not on a 45, 45. There's no short leg on this. This is 45, 45. Square root of 2 times what? The leg. The leg. The hypotenuse is right here. Hypotenuse is equal to the square root of 2 times one of the legs. What did I decide to call one of the legs here? X. So I'm going to call this X. Okay? Now, let's fill some stuff in. I know the hypotenuse on this particular triangle, don't I? Yeah? So let's fill it in. So what is the hypotenuse on this triangle? It's a 1. Do you agree? All right. So what I'm going to do is I'm going to solve for x. I want to find out what x is equal to. And I'm going to show you something that's pretty important. So let's solve for x. How do I solve for x? Multiply? What? By 2? First of all, I don't multiply to get rid of that, to get x by itself. No, don't have to do that. How do I get rid of x? How do I solve for x? How do I get x by itself? Divide it by what? The square root of 2. Square root of 2 is just a number, just like anything else, okay? It's not a 2, all right? It's a square root of 2, which is like 1.14 something, or 1.414, I think. Yeah, 1.414 something, all right? But I'm not going to write it as a decimal. I'm just going to keep it square root of 2. It's just a regular number. So I divide it by the square root of 2. They'll cancel out, right? What do I have to do to the other side? Divide that by square root of 2. So that cancels, that cancels. What's x equal to? 1 over the square root of 2. I got a little problem with that, though. What's the problem? Yeah, exactly. Can't have a square root on the bottom. So I do a thing called rationalizing the denominator. You don't really have to know the name of that, but that's what it's called. What's the little, I don't know, trick, I guess we'll call it. You got it. Multiply not just the bottom by the square root of 2, but also the top by the square root of 2. Why can I do that? Why can I put square root of 2 over square root of 2 and multiply it? Because what's the square root of 2 over square root of 2? It's a 1, isn't it? What's anything divided by itself? It's a 1. Am I allowed to multiply anything by a 1? Yeah, I can. It's not going to change the value of it, is it? So am I allowed to multiply this by 1? Sure. Okay, it doesn't change it, does it? But it changes the look of it. Why does it change the look? Because I'm going to get rid of that square root. So now let's multiply the bottom, multiply the top. What's the square root of 2 times the square root of 2? It's just a plain old 2. Okay, so square root of 4, right? Because you multiply them together, put them under square root. What's the square root of 4? It's 2. But I wouldn't even think of it like that. When you multiply a square root times itself, it just gets rid of the square root. And we're left with just the one number underneath, which is a 2. Remember doing that? What's the square root of 7 times the square root of 7? It's just, no, don't think square root of 49. I just said, look, square root of 2 times square root of 2 is 2. Square root of 7 times square root of 7 is 7. What's the square root of 247 times the square root of 247? 247. You got it? So you don't have to multiply them together and then take the square root. Just think of it. When I multiply it by itself, I'm basically squaring it, aren't I? When I multiply something by itself, yeah? You guys thinking? Okay. Seems like some of you are starting to doze a little bit. So when I multiply something by itself, I'm squaring it, which means it gets rid of the square root. All right, let's do the top. 1 times square root of 2 is square root of 2. See that number right there? That's a super important number that you're going to have to memorize and you're going to use a lot. A lot, okay? So I'm going to write square root of 2 over 2. Why did I do that? What does this have to do with sine, cosine, tangent? Well, I'm glad you asked because I'm going to show you. All right? So let's do it. Let's find the sine. Now, it's not just the sine of theta or not just the sine of A. I actually know the angle. So this is the first time we actually know one of the angles we're going to take the sine and cosine and tangent of. Okay? So this is the angle, 45. So I'm going to write the sine of what? 45 degrees. You with me? What does that mean, the sine of something? Well, it means I'm going to take that 45 and I'm going to take the ratio of the opposite over the hypotenuse, correct? All right, so let's do that. What is the opposite of this 45 right here? Square root of 2 over 2. Oops, let's put it up here. Square root of 2 over 2. Over the hypotenuse. What's the hypotenuse in this situation? It's a 1. All right, well, what's anything divided by 1? It's just whatever it was, right? So square root of 2 over 2. So if you're walking down the hallway, right, I'll tap you on the shoulder and I would say, Zvinka, please tell me what is the sine of 45 degrees? What would you tell me? That's it, the square root of 2 over 2. All right? If you don't believe me, let me show you. It's this one. If anybody's watching this on YouTube, which I doubt many people are, but if you are, I have a calculator up here and I'm just putting in the square root of 2 over 2. So let's put the square root of 2 over 2 and, oops, one thing, have I used this calculator with you guys? One thing I have to do is, actually, no, I don't want to do that. Let's clear. Oh, go to mode. See how it says radian right here and it says degree? This one defaults to radian every time I turn it on, and I have to put it in degrees for this to work. All right, everybody see that? So it's in degrees now. So now it'll work. So what I'm going to do is I just want to show you that the sine of 45 actually is the same thing as the square root of 2 over 2. All right? Just show you with a calculator. I'm not going to do this like every single time, but I think the first time it's good to show you. So square root of 2 over 2. On a calculator like this, hit second function, hit this button right there. There's your square root of 2, close the parentheses, over 2. How do I show that on a calculator? Divided by 2, and that equals that number right there, 0.707, blah, blah, blah. Everybody good? Now, I just want to show you. So that should equal the same thing as the sine of 45. Agreed? So let's do it. Let's hit the sine button. On this calculator, you hit sine. Like on my graphic calculator, on my calculator on my phone, I have a scientific calculator like this. If you have a scientific calculator like this, a lot of your calculators, you would hit 2 first and then the square root. I think that was the very last thing we talked about on Thursday. Do you remember that? Yes. Well, I'm just talking about square root of 2 over 2, not talking the sine yet. Okay? I'm just talking about the square root of 2 over 2. How do you put that in the calculator? All right? You put, if you had like a quote, regular scientific calculator, you would put 2 first, and then you would put square root. All right? And then you would take that and divide it by 2, you get the same number. So make sure you know how to use your calculator. Do you guys have your calculator with you? If you do, try it. Make sure you're getting that number, okay? All right, that's pretty important. Now, I want to show you it's the same thing as the sine of 45. So on this calculator, I can hit the sine first and then hit 45. If you have one of the smaller scientific calculators and not a graphing calculator, some of your calculators, you hit 45 first and then you hit the sine. All right, so just depends. So I'm going to hit enter, and look at that. Same exact number, all the way to all those decimal places. How many decimal places is that? That's 6, 7, 8, 9, 10. Is that 10? 3, 4, 5, 6, 7, 8, 9, 10. Yep, 10 decimal places. And it's exactly the same number. So would you agree that the sine of 45 is the same thing as the square root of 2 over 2? Absolutely. All right. Let's put this calculator off to the side a little bit. Let's do a little bit more. Let's find the cosine and the tangent of 45. Well, the cosine of 45 is the adjacent over the hypotenuse. The thing is, the adjacent and the opposite are exactly the same thing, aren't they, on a 45-45? So what do you think that's going to be? It's going to be the square root of 2 over 2 over 1, which is the same thing as what? The square root of 2 over 2. Let's see if it works on the calculator. So let's hit cosine of 45, and let's see what that is. Sure enough, it's the same exact number. Make sure it works on your calculator. You need to know how to make it work on your calculator. Again, some of your calculators, you would hit 45 first, and then you would click on cosine. But some of your calculators, you hit cosine first, then you hit 45. Make sure that you know how to work the calculator that you're going to use on a quiz or a test. All right? Does that make sense? All right, let's do another one. Let's do the tangent of 45. Well, what's the tangent? In general, what's the tangent of that angle? It's the what over the what? No. Toa. Opposite over adjacent, okay? So it's opposite, which is square root of 2 over 2, over the adjacent. Which one is adjacent? Square root of 2 over 2. Do you really have to do any arithmetic with this? What's anything divided by itself? It's a 1. So what's the tangent of 45? It's 1. Let's see if it is on the calculator. So I'm going to hit tangent. I'm going to hit 45, and then enter. And look at that. It's a 1. It's not a 1 point any decimal. It's just a straight up 1. That's the tangent. So finding the sine, cosine, tangent of 45 can be very, very important. Everybody with me on that? Okay. Let's just push that over. All right. So that is 45, 45, 90. What's another triangle we dealt with? Special triangle. 30, 60, 90. So let's draw one that kind of looks like that. All right, so we'll draw that. We got a short side and a long side, right? on 30, 60, 90. And there we go. We'll call this our 30-degree angle. We'll call this one down here our 60-degree angle. Let's write a few things that we remember. Hopefully we remember from, I don't know what, 2 chapters ago, something like that. Remember, they both have to do with the short leg. So now, somebody said earlier with the 45, now's the time.
The pretzel sale this afternoon at 3 p.m. in the lobby. And then also a reminder, sophomores who registered for the PSATs, you will be taking them tomorrow at 8 o'clock. So please make sure to bring your devices for that. Thank you.
Okay, so remember on a 30, 60, 90, what was true about the hypotenuse? It was what? Twice. No, it's not a square root for the hypotenuse. Hypotenuse was what? Twice the short leg. All right, the hypotenuse is exactly double this short side right here, that short leg. Okay, what was the long side? That was the square root of 3, right, times the short leg. We good with that? Okay, so let's keep that in mind. What did we make? I made one of the sides equal to something on the other triangle. What did I make before we actually started doing the math? Nah, well, because it was 45, 45. So I didn't really make them equal to each other. On a 45, 45, they're always going to be equal to each other. But what did I specifically make one of the sides equal to? No? 1. Right, I said the hypotenuse was 1. There's a reason for that. Maybe later on when we start talking about a unit circle, if we talk about the unit circle, I'll explain why I made it 1. But you know what I should... that's okay. I'll just leave it like this. This is fine. So let's make that a 1. So what do I want to do? I want to find the short leg, let's just call it A, and the long leg, let's call it B. Is that all right? Doesn't matter what you call it. Could have called it X and Y. I just called it that. So let's find A first. That's the short leg. All right, it's our important one. So I know the hypotenuse, and I'm trying to find the short leg. So I use that first little formula right there. Hypotenuse is 1 equals what? 2 times the short leg. What's the short leg? It's A. So divide both sides by A. So what is, oops, what am I doing? Not by A, that's silly. By 2. Trying to find A. All right, so those cancel. So what's A equal to? It's 1/2. So that's kind of nice. All right, so when the hypotenuse is equal to 1, the short leg is 1/2. That makes sense, doesn't it? Yep, because if that was twice as big as the short leg, twice as big as 1/2 is 1. All right. What about B? Well, let's use the second formula. B is the long side, right? So B equals the square root of 3 times the short side. Well, I just found the short side, didn't I? What was the short side? 1/2. So what's B equal to? Let's multiply all that together. Square root of 3 times 1 is just the square root of 3 over 1 times 2 is 2. So these numbers right here are other numbers that are really, really important. And you're going to be saying them a lot. Okay? That 1/2 we're going to use a lot. The square root of 3 over 2 we're going to use a lot. We're also going to use that other one, that square root of 2 over 2, when you have a 45-degree angle. Okay? Now, why did we go through all that mess? I can get rid of all this now. Because what I want to do is I want to find the sine, cosine, and tangent of 30 degrees. And then I want to find the sine, cosine, and tangent of 60 degrees. So that's a bunch of stuff that you're going to be able to figure out. And it's without using a calculator and all that kind of thing. All right, so let's do it. Let's find the sine. Let's do the smaller one first, 30 degrees. Okay, what is the sine of 30 degrees? Here's our angle. So what over what is the sine? It's the opposite over the what? Hypotenuse. Good. This is the sine over the hypotenuse. So here's your angle right here. What's the opposite sine, or the opposite side of 30 degrees? It's 1/2. Over the hypotenuse. What's the hypotenuse? 1. So what's the sine of 30? It's 1/2. We'll put that in the calculator in just a couple minutes, okay? Let's do all 3 of these first, and then we'll put it into the calculator. So the sine of 30 is a half. What is the cosine of 30? Well, the cosine of 30 is the adjacent over the hypotenuse. So it's what? Square root of 3 over 2 over what? 1. Everybody see that? Because your hypotenuse is 1. It's adjacent over hypotenuse. And what is that? It's the square root of 3 over 2. Again, that's a number we're going to have to know. Let's find the tangent of 30. What's the tangent? Well, no. It's the opposite over the adjacent, correct? So it's not 1/2 times. It's divided by, right? It's the opposite over the adjacent. Square root of 3 over 2. Let's do a little math here. On this one was easy because it was over 1. We didn't really have to do any division, did we? On this one, we have to do a little division. So I'm going to take that top divided by the bottom. What's the same thing as dividing by a fraction? What do? If I divide by a fraction, it's the same thing as multiplying by the reciprocal. Anybody recall that? Yeah? Okay. I don't know if you guys realize how the importance of what we're doing right now. Okay, this is not just another lesson. This is a landmark lesson. There's a few lessons that are landmark lessons, like Pythagorean theorem. That was a landmark lesson. All right, this right here, it's a landmark lesson. This is a big deal. So I hope you're with me. All right, the 2's canceled. I got 1 over square root of 3. What's the problem with that, though? Got to square it on the bottom. Let's do that really quick. We already explained it earlier, so I'll just do it real fast. Multiply top and bottom by the square root of 3. The bottom, square root of 3 times square root of 3 is just a 3. Then the top, 1 times the square root of 3 is just the square root of 3. That is an important number as well. So here are the sine, cosine, and tangent of those. All right, let's put it into a calculator. It turned off. How do I turn it back? Oh, here we go. All right. Let's just clear everything. All right, so let's do this. Again, if you're watching on YouTube, you won't be able to see this because I got a calculator up there and I just can't get it to come on the screen when I record this, but this class can see it. Well, you know what a half is, right? It's 0.5. So let's see on the calculator if it really works. So let's take the sine of 30 degrees. Let's see what we get. Look at that. That's a half, isn't it? Do you agree? All right. Let's find the cosine of 30 degrees now. So now we're going to do the cosine of 30 degrees. And that's equal to that crazy number. How do I know what that number is? Well, let's put in the square root of 3 over 2 and see what it is. All right, so here's the square root of 3 divided by 2. Look at that. It's the same exact number, isn't it? So would you agree that the cosine of 30 is equal to the square root of 3 over 2? Yeah, because the square root of 3 over 2 is that 0.8660 whatever. All right, let's do the tangent of 30 now. Tangent of 30. And that equals that crazy number. 0.577350, blah, blah, blah. How do I know if that's equal to this? Well, let's put it in. Let's put the square root of 3 over 3 in and see what it is. So, square root, oops. How do you go backwards? Do I just delete? How do I delete just that line? I don't know. Let's just hit enter. Forget that 0.33 that's right there. I just can't figure out how to get rid of that thing. Let's do this. What am I doing? Square root of 3 over 3. So the square root, there we go, of 3 divided by 3. And that's equal to, look at that number right there. Isn't that the same thing as the tangent of 30? So the only reason I use the calculator on here is just to show you that that these things are true. All right? We're almost done, I promise. So what I'm going to do now is this. Without even, well, you got to think a little bit. But do you remember that thing where I did earlier when I did that crisscross thing? Yeah? Let's go back to it real quick. This thing right here. Look, the cosine of A should be the same thing as what? The sine of B. So let's go back to this. So what do you think the cosine of 60 degrees is? So this time we're going to go to the 60 and use this one. Instead of going adjacent over hypotenuse, the sine of 30 should be what? The same thing as the cosine of 60. What was the sine of 30? 1/2. What do you think the cosine of 60 is? Should be 1/2. Let's just see if it is. Cosine of 60 is adjacent over hypotenuse. 1/2 over 1 is 1/2. Yeah, it works, doesn't it? See how that's true? What do you think the what do you think the sine of 60 is? If you've already done the cosine of 30, what do you think the sine of 60 is? Square root of 3 over 2. That's right. Okay, it should be the exact same thing. Let's take a look at our triangle and see if it is. The sine of 60. The sine of 60 is the what? The opposite over the hypotenuse. Square root of 3 over 2 over 1. Yep, it works, doesn't it? Now, what do you think, we'll do it down here, the tangent of 60 is? Now watch, remember, instead of doing this, let's use this one right here. Remember, that was the tangent of 30, right? We just had to simplify it so it didn't have a square root in the denominator. So what do you think the tangent of 60 is? You remember how we figured out what the tangent was? Look, the tangent of A is equal to the inverse or the reciprocal of the tangent of B. Make sense? So you just flip it. So what do you think the tangent of 60 is without really doing any math at all? It's just the square root of 3. Let's see if it is. The tangent of 60 is the opposite over the adjacent. So that would be the square root of 3 over 2 over 1/2. Let's see. Square root of 3 over 2 times what? 2 over 1. That cancels, that cancels. Look what we get. We get the square root of 3. So if you know the sine, cosine, and tangent of the one angle, finding the sine, cosine, and tangent of the other angle is pretty easy if you know those relationships. You see it? Sine of 30, cosine of 60, same thing. Cosine of 30, sine of 60, same thing. The tangent of 30 and the tangent of 60 are just reciprocals. See how it works out? Yeah. All right. I think, well, what do we got? 4 minutes? Yeah, I'm not going to do that. It's just gonna, I would just be trying to force it in there. Maybe tomorrow, maybe I'll talk about it. But we are ready now to finish that homework. Okay? Hang on just a second. Let me write this down. So before, what did I give you? Like 13 to something? No, I didn't give you anything, did I? Or did I? Yeah, I gave you 1 to 12. I gave you 1 to 12, right? Okay. Oh, that's right. I got it right here. So this is 13 to 38. Now, it seems like a lot, but some of these are really easy. Some of them are you just punch the stuff in a calculator. Literally, it'd take you seconds to do each of those problems, okay? So it seems like a lot, but really, a lot of not all of them, but a lot of these problems are very, very short, okay? Because it's just putting stuff into a calculator. Not all of them, but quite a few of them are, all right? So this is section, what is it, 12.1b? And you're doing, what I say, 13 to 38. So tomorrow we're going to go over both of those. We're going to go over 12.1a, 1 through 12, and we're going to go, so basically tomorrow we're going to go over 1 to 38. Not every single problem, but ones that you have questions on. Yes, ma'am. Which one? 31? Let me see. All right, let's take a look at that real quick. I think this is how they're going to do it. You could do it this way. So here's what they give you. Everybody look. It says the cosine of b. They don't give it to you as a fraction this time. They give it to you as a decimal. No, are you listening? I don't think so. All right, they give it to you like this, and they ask you to find the sine of b and the tangent of b. Is that correct? So what you could do is just make a little triangle. Doesn't matter. We'll call that b. All right. So the cosine is the adjacent over the hypotenuse. Now, I don't know what that is as a fraction. I don't know if it comes out to a nice perfect fraction or not. I kind of doubt it does. But what you could do is this. You could make the adjacent, remember this is adjacent over hypotenuse, you could make this 0.8192. And then you could make the hypotenuse what? A 1. Right. But the problem is, not the problem, well, it kind of is. You're going to have to find this side right here, aren't you? Do Pythagorean theorem, right. So do Pythagorean theorem, use calculator, right? Do Pythagorean theorem, find this, then you can find the opposite over the hypotenuse. Then you can find the opposite over the adjacent. Okay, but you got to find this, though, first. So that's how I would do that problem. Does that make sense? Okay. All right, have all that done for tomorrow. We'll go over that tomorrow.